And joining me on the call here today is my colleague, Nick Van Ecker, who is a fellow educator at the museum. Yep, and that's him saying hi. So for those of you who are new to Science on a Sphere, it's a program created by NOAA, the National Oceanic and Atmospheric Administration. And it's this big fiberglass great ball hanging from the ceiling with projectors surrounding it that allow us to see all sorts of big planetary data sets to explore lots of topics and ideas within science and culture. And today we're going to be using the sphere and these big data sets to solve a mystery. We'll be working together to solve the mystery of how a penguin feather from the Antarctic can end up all the way in California on a beach called Ocean Beach. And so we'll get started with a short clip. The audio might be a little bit difficult to hear, so I'm going to be narrating over it, and Nick will be sharing the data sets and the videos throughout today's show if you want to check it out on your own time. So we'll go ahead and play that. All right, so we're beginning the story of a penguin feather. And in this specific story, there are a whole bunch of volunteers that have gathered together to pick up pollution, debris that has washed up on this beach called Ocean Beach. And okay, there we go. I got the video. And this specific volunteer picks up this shoe from the beach just to show you like the amount of pollution that ends up washing up ashore, and that little red blob is supposed to be the shoe. And this same volunteer ends up finding a whole bunch of feathers along the shore, and she finds someone in the volunteer group who studies a whole bunch of birds. And this person identifies this really strange looking feather out of all of them that she's holding up right now. And she actually says that's a penguin feather, which is wild because how did it end up all the way up there? So one of the factors that really impacts where things go around the Earth is currents. And so I have a data set behind me that's showing a specific type of current. I'm turning the sphere so that we can see a little bit more of it. But these currents are going all across the Earth, as you can tell, and they're very complex. The blue is meant to represent the colder currents, while the red is supposed to be representing the warmer currents. And we have a short little demonstration for you that Nick is going to be playing with one of the previous student presenters, Alina, to kind of show a little bit more about these warm and cold currents circulating around the Earth. Nick, are you ready to share screen? Oh, nice. Okay.
Yes, and I just need to make sure that the audio is going to be working too.
Perfect.
Be able to hear that?
No, I think you need to do the share sound.
There it is.
Filled with a couple of inches of warm water, a few drops of food coloring, whatever color you'd like, a couple of rocks or cups. We need a flattish bin or pan filled with a couple of inches of warm water, a few drops of food coloring, whatever color you'd like, a couple of rocks or cups if you can't find any rocks, and a bunch of ice cubes. So 6 is probably a good number. Alrighty. Cue the video. Alrighty, so for this activity, we just need a pan, some warm water, some ice cubes, and a few drops of food coloring, and we can understand how ocean currents work. We take a large container like this and fill it with a couple of inches of warm water and some rocks. The warm water represents the oceans of the world, and the rocks represent the continents. Alright, let's see what happens when we add a drop of food coloring. Not a whole lot. It hits the bottom and it just kind of spreads out from there, right? Alright, what happens if I add some ice cubes to the water? Add as many ice cubes as you want. Alright, let me add one more drop of food coloring. Maybe over here. Maybe over here. Alright, let's watch what happens when the discolored water hits the continents and how it moves. So you see it is actually moving in directions now. So in the pan, the cold melted water from the ice cubes is denser than the warm water in the pan. That means that there's more water packed into the same amount of space. So that colder water drops to the bottom of the pan and moves along the bottom until it warms up, and then it rises up to the top again. The same kind of thing happens in the oceans. So like the oceans, like the pan, the oceans of the Earth are not all the same temperature. The North Pole and South Pole are a lot colder. So that cold water drops to the bottom of the oceans and it moves towards the equator until it gets to where all that warmer water is as it warms up. So this creates large-scale deep currents. These currents are responsible for moving large amounts of water from one part of the world to another. Let's see, we've got these little currents moving around here. We kind of just created our own currents in this pan. And they're still moving. Just kind of mixing all together.
All right, thanks, Nick. So she explained it very well, that when she put the ice cubes in certain areas of that pan, it created a temperature difference. And the same data set is behind me, but that temperature difference creates warmer and colder water that end up moving around the Earth, changing the temperatures and moving all sorts of things around to different waters around the Earth. And so let's take a closer look at this data set. And throughout this presentation, I'll be asking a couple questions just to keep it a little bit more interactive. So I want to ask you all right now if you think this current, these thermal currents, are enough to bring a feather from all the way down south near the Antarctic to this beach in California. And I'll just wait a second for any answers or ideas that you might have. Okay, so to me, like, it looks a little bit farther away from the coast. It might be a little bit hard for that small little feather to reach all the way up to California. But thankfully enough, these thermal currents aren't the only things creating waves and moving around water in the ocean. So wind blowing across the surface creates what we call surface currents that could catch our penguin feather that we're looking at. And behind me on the sphere is all the wind, all the currents that are being created by wind, are surface currents that also help move water around. And if the penguin feather gets caught in what we call an upswell, where it is taken from these deep deep currents where the cold water is, and is swept up into a warmer, more surface level current, it could very easily be moving further than Hawaii and a lot closer to San Francisco, where our volunteer had found that penguin feather. So we're going to be looking at a possible solution as to why that penguin feather ended up in California. And this handy data set is combining those that thermal current data set that we just saw, and now the wind surface current data set, to give us a picture, a more intricate picture of how water is moving around the earth. And we see that maybe that feather got taken up by that deep current, moved all the way across the Pacific Ocean, and then got deposited by those surface currents on the beach. And so we have a little graphic showing maybe where that penguin, how that penguin feather traveled. And so using these two different types of currents, it's very possible that that's how the feather traveled. The thing is, it takes a really long time for that to happen, on the order of like 500 or so years. So it's possible, but perhaps unlikely just because of the time it would take. But it brings up a really interesting point about the ocean and how interconnected it is. Could an object placed in a certain part of the ocean end up anywhere if it stays long enough? So scientists have run simulations to see what would happen if you add an object to the ocean. And a really interesting application of this, and a really important one nowadays, is regarding pollution. So is pollution that's added to a certain area of the ocean contained in that area? Does it spread? How far would it spread? So we have this data set here that's showing us what might happen if we add a certain pollutant. And it starts around Australia, and that little ticker that you see behind me is just the number of years that it's taking to travel. And so we're going to explore and see where this pollutant is going to end up. And it's quite a long data set, so I'm going to fast forward a little bit. But it's around the Indian Ocean, and then it circles there for a while before around 50 years, it finally crosses South Africa. And then we'll continue. I'm going a little bit fast, but it circles around in the North Atlantic for quite a while, for about 100 or so years, until it travels up into the Arctic regions and stays there for another little while. And then it gets stuck up in that island. We'll continue to fast forward a little bit. And then it gets caught in a current that brings it back down south, a colder current actually. And now we're at about 260 years. And you'll see that if this simulation goes long enough, and I'll fast forward again, it'll travel on these cold currents right around Antarctica. until it catches a warmer current. And continues its way across. And so it ended up basically where it came from, which is so interesting. The idea that there are the 7 seas or a number of different oceans is really a misnomer. As we just saw, the oceans are very connected. And so anything that happens to one part of the ocean ends up affecting another part of it. But we have solved the mystery of the penguin feather, and now we're going to learn a little bit more about penguins and their relationships with these major ocean currents. So when we talk about penguins, a certain image kind of gets put in our mind. And I want to ask you all real quick, what comes to mind when you think about penguins? And feel free to put that in the chat. Okay, I know I think about the cold a lot. I definitely think about the Antarctic. And one question that we want to think about real quick before moving on is if all penguins actually live in Antarctica. So there are around 25 different species of penguins around the world. And I have a handy map that is going to tell us where they live, if it comes up. Let's see. Might be a bit hard to see. Wait for it to adjust. But all these light blue areas, you can see them maybe a little bit easier now. But all these light blue areas are where penguins live. And you might be noticing that a lot of them are near the waters, so on the coasts of lands. They're pretty much near the southern hemisphere. But there's this one very interesting place that I want to zoom in on real quick, if we can see it. It's a little bit hard to see on the screen, but there's this very strange light blue dot that's very close to the equator. And some of you might already know what I'm hinting at, but we're going to be talking about this very interesting island and the penguins that live there. So there is a wide variety of penguin species, but today we're going to be talking about 3 different ones. The emperor penguin, which most people might already know, the little penguin, and also the Galapagos penguins. So we're going to begin with an emperor penguin, and I'm going to just take out that magnifying glass. And this map right here is showing us where emperor penguins live. And they live pretty much exclusively in Antarctica. And this is a picture of one. And we actually have a plushie that is pretty accurate to the size of a real emperor penguin. And hopefully you all can see. But it's pretty big. It's almost half the size of me. And this penguin is the largest species of penguin, actually. And so the next one that we're going to touch on real quick is the little blue penguin, and where they might live. So I'm going to clear off that map. And this is actually what they look like. It might be a hint to you as to where they might live. feel free to put your guesses in the chat. And Nick has just put a nice Wikipedia page with more information about the little blue penguins. But yes, we have a guess that says Australia. You're exactly right. They live in both Australia and New Zealand in really specific places. So maybe, there we go. So they live all around New Zealand and then a very, the southern half pretty much of Australia. So that's the little blue penguin. And we actually have a little plushie of that one too. And it's very small, only about the size of a blade of grass, to be honest, like that height. And it's the smallest species of penguin. Now, what about the Galapagos penguins? So the Galapagos penguins live on the Galapagos Islands, which is a very interesting place. So I'm gonna pull up a picture of one. And Nick has put it in the chat as well, if it's hard to see on the screen right now. But the Galapagos is really interesting, and I'll also put up their range now. So it's zoomed in a little bit on where the island is, but the Galapagos are off the coast of Ecuador and the South America region, and it's pretty much like right next to the equator. So given how penguins really love warm temperatures, it's really strange to think about this species of penguin that's thrived there in a place that we think is supposed to be really hot. And their range is pretty much just on these islands. And so you all might already know the answer for why penguins might be able to survive there, but if you want to put in a guess in the chat or in the Q&A, you're more than welcome to. But why might Galapagos penguins be able to live in what we think is supposed to be a really hot region? And I'll wait a second for any guesses. So we explored this a little bit earlier today, but the big reason is because of these ocean currents. And there's one specific one that we're interested in. And this data set is pretty cool. It's showing all the currents around the Earth along with their names. The one that we're specifically interested in is this one that's moving from the Antarctic region all the way up here. And it's called the Peru current or the Humboldt current. And it's carrying all that cold water from the Antarctic and circling it around the Galapagos Islands, making sure that the penguins who love the cold can actually live there. So ocean currents act like the circulatory system for the Earth, just like how we have our own circulatory system, bringing oxygen, keeping our bodies warm if we're in extreme temperatures. These warm and cold currents circulate around the Earth and bring warmer or cooler temperatures so that life can thrive everywhere. So ocean currents help move around cold and warm water, but they're also affected by changing temperatures. So what do you think would happen to ocean currents if the same temperature was everywhere around Earth? Would they still move around? So feel free to put it in the chat or guess in the Q&A. Oh, we did have a guess on the Galapagos penguins, that they might have less feathers and blubber than other penguins. Yeah, it's very possible that they did adapt to the conditions in the Galapagos, but it's also that adaptations plus the currents that really united to allow them to live in that really interesting area. Moving back to the ocean currents, there wouldn't be any ocean currents if the entire Earth was the same temperature, because as we saw in the earlier data sets, the cold waters are what create the deep currents that move around large amounts of water, and the surface currents are the warmer ones that also help move around things to where they need to go. So both of these temperatures work together to move around large amounts of water. And so if the Earth was all the same temperature, these ocean currents would stop, which is part of the situation related to climate change. So as global temperatures change due to the increased CO2 in the atmosphere and these melting ice caps, it changes how the current works. And that affects penguins, but also the weather, the climate, and ultimately us. So that's kind of all we have for you today. Thank you so much for joining us today on the mystery of the penguin feather. Feel free to stick around if you have any questions. Oh, and I was late to check the Q&A again, but yes, the oceans would be stagnant if the entire Earth was the same temperature. But yeah, feel free to stick around if you'd like, and feel free to ask questions about different data sets or this show here today. But otherwise, thank you so much for joining us, and we hope you enjoyed the show. Oh yeah, thank you for coming.